So today we are going to be looking at a new way to solve systems. So we've already talked about solving systems by graphing, and we've talked about solving systems when they're inequalities. So today we are going to look at how we solve systems by substitution. Sorry, I did not write that well, but okay. So we're looking at systems, which again, remember, that means two equations, two variables. So we're going to still have those two equations and two variables going on. But we want another way to be able to solve. Now, one thing you have to be careful of is you can't just say, I will always solve by graphing. Because while graphing always works, we might have to approximate a solution, or it might just be so large it'll be a pain in the butt to graph. Okay, so I'm going to give you an equation here. Y equals, or a system, I should say, y equals x plus 3, and y equals x minus 1. Yes, this is one that we could solve by graphing fairly easily. Okay, but we're going to pretend that we're not going to do that just because I want us to be able to work with small numbers to start with so we can get a hang of substitution without doing something big and complex for our first one. Okay, so when we are solving a system by substitution, that's exactly what we want to do. We want to substitute. And remember, substitution is where we swap one thing and we put it in place of another. Okay, so to find that means we need to identify two equivalent things. So our first step when we are solving by substitution is we want to find either an x equals or a y equals. Okay, we want x equals or we want y equals. And when we find it, we are going to circle it. Okay, so we're going to look at the equation. We're going to look for an x equals or y equals. Now, keep in mind it has to be that x sitting by itself or that y sitting by itself. That's what I mean by x equals or y equals. So when we look over at this system, right, we actually have two places where that's happening, right? Both of those say y equals. So we are just going to have to pick one and we are going to circle it. So I'm going to circle this top y equals. I'm just circling the y. That's where I see the y equals. Okay, for my step 2, I am going to underline what it equals. Okay. Now, just like we normally say, it's not like I'm going to take off points if you don't underline, right? It's not like this is a rule that's set in stone that if you don't do mathematically you're wrong. But right now, these are going to be our visual cues for us to make the correct substitution. So what does y equal? Y equals x plus 3. So that tells us right now that y is the same value as x plus 3. Just like 10 is the same thing as 5 times 2. They look very different, but they're the same value. Okay, our third step is that we are now going to go to the other equation. Okay, so we're going to look at the other equation, the one we haven't touched yet. Okay, and we are going to cross out the letter we circled. Oop, that's not how you spell letter. Try that again. Okay, so we circled a y. So we are going to cross out this y. Now I sort of scribble it. You can do whatever. And then our last step here is that we are going to replace what we scribbled out with what we underlined. So I underlined an x plus 3. So where we scribbled, I'm now putting in x plus 3. So if I read this bottom equation that I now just wrote straight across, it now says x plus 3 equals x minus 1. And now I have a new equation that I am able to solve. Now, again, I picked something super simple to start with just because I wanted us to understand the substitution process. So now let's go to start solving this. Okay, so in this equation, we have variables on opposite sides of the equal sign. When they're on opposite sides of the equal sign, we get them together with the opposite sign. So I'm going to move a positive 1x with a negative x, right? Those x's cancel out. I get 3 equals negative 1. Is 3 equaling negative 1 a true statement or a false statement? Should have said false, right? And if it's a false statement, what do we then think our final answer will be? This is a no solution. Now, obviously, again, I picked one that was super simple to start with just because I wanted us to get this substitution process. These over here are steps for substitution. So let's see what happens when we go through and we have a problem we can actually solve all the way through. Okay, so let's say we have x equals 2y minus 3. And x equals 3y minus 7. We have a system. We have 2 variables. We have 2 equations. So our first step is going to be to see where we see x equals or where we see y equals. We see x equals twice. So because we see it twice, we can just pick one. So I'm going to circle the top one. Our next step then says we want to underline what x equals. So in this case, x equals 2y minus 3. So now I'm going to go to that other equation and I'm going to get rid of the x and I'm going to replace it with what it's now equal to, right? X is now the same thing as saying 2y minus 3. And I have a new equation that says 2y minus 3 equals 3y minus 7. Okay, this is something we know how to solve. So when we have variables on the opposite side of the equation, we want to get them together with the opposite sign. Okay, so usually we're moving that smaller one. So we're probably going to move a positive 2y by subtracting 2y. So we'll get negative 3. 3y minus 2y is 1y minus 7. We will then undo subtracting 7 by adding 7. Right? These are just our steps for solving an equation. If this part is a struggle, we definitely need to be working on those solving equation rules. So reach out to me. Okay, so we'll do negative 3 plus 7, which will give us 4 equals 1y, right? Which is the same thing as y equals 4. Okay, so great. We solved this equation for y. However, remember a system has an x and a y solution. So we know that our y value in the coordinate, the ordered pair, our y coordinate is 4, but we still need to find the x coordinate. So what we're going to do to find that x coordinate is we are going to take this y value and we are going to plug it in back up here where we underlined. Now, truly, you can plug it into either of the original equations. It's just going to be less work to plug it in where we underlined. Okay, so now instead of saying x equals 2 times y minus 3, we're going to say x equals 2 times 4 minus 3. Okay, so we'll have x equals 8 minus 3, 8 minus 3, and so our x value is 5. Now remember, this tells us that x equals 5 and y equals 4, where if we were to plug 5 in for x and y in for 4, we would get true statement on both equations. Let's look at one more example here. Let's say we have x equals 60 minus y, and 5x plus 3y equals 220. Which variable would we circle first? We should have picked x, right? Because that's the one that's by itself. Okay, and so we're going to underline what it equals, which is a 60 minus y. What letter do we want to cross out in the second equation? Yep, we want to cross out that x. Now be careful, we are not crossing out 5x. We are only crossing out the x. Right? And we are going to replace it with 60 minus y. I'm going to use another color here so we can see it better. Okay, so remember, this problem did say 5 times x, And now it needs to say 5 times 60 minus y. And then I'm just going to keep going straight across. Plus 3y equals 220. We should know how to solve an equation like this. Okay, so we're going to distribute. So 5 times 60, again, 5 times 6 is 30. We're just adding an extra 0 on it. Minus 5y plus 3y equals 220. These variables are on the same side, so we are getting them together with the same sign. So 300 minus 2y equals 220. Minus 300. Again, this is just solving. If this part is overwhelming, we definitely need to touch base. Equals a negative 80. We'll then divide by a negative 2 and get y equals 40. We are not done because, again, this only tells us our y value. So we know that y is 40. What are we going to do to find our x? Yeah, we need to take this 40 and we need to plug this all the way back up in here for our y. So we're going to say x equals 60 minus y, but y is now 40, so 60 minus 40. So x equals 20. And our final answer will then be x is 20, y is 40, or we could write it as 20, 40.